All right, this is CS50, and this is our week on SQL, or SQL, for Structured Query Language, which is a programming language specifically for talking to databases. Now, over the course of this lecture, what we're going to do is solve some problems in new and different ways by transitioning from that other language, Python, which it turns out is very multi-purpose. And indeed, this is thematic with Python in that you can do so many things with it, but it turns out there's certain things you might want to do in computing that maybe aren't ideal for a language like Python, let alone a language like C. And so you might want a more specialized language that makes it easier for you to get real work done. And indeed, this has been true over the past several weeks. We started with Scratch, we transitioned to C, we then transitioned to Python. And there's actually a lot of overlap in those languages in what you can do. They're not perfectly complementary. I can't imagine doing some of the things we did in Scratch using C. But what we will see today, no pun intended, is that using a domain-specific language, something specific to databases in this case, you can actually save a lot of time and express yourself a lot more readily with a lot fewer lines of code than something like Python allows. But before we do that, I dare say it would be ideal if we have some data that we can play with, so we have data to put into a database. And let me propose that we go ahead and collect some live data here. So if you'd like to go to this URL here that's on your screen, if you're on a laptop or desktop, or if you simply have your phone in front of you, feel free to scan this code here, which will lead you to a Google form via which we're going to collect some information from everyone here. I'll go ahead and in just a moment transition to just a screenshot of what everyone here is seeing, because if you're watching this on demand thereafter, the form probably won't still be open because we can't take data from the future into account today. But what we'll have here is a Google form via which we're going to collect some information from everyone here in the room virtually. And this form asks two questions. One, it asks, what's your favorite language? The options for now being Scratch, C, and Python. And it also asks, what's your favorite problem from recent problem sets? So go ahead, take a moment, and fill out that form. And in just a moment, we'll see that these responses are being gradually collected. Not in the context of the Google form per se, but in a more useful format for today's purposes, that of a Google spreadsheet. In fact, let me switch over to my other laptop here, where I have full screened all of the responses as they are coming in. You'll see that all of them are timestamped for a particular day and time on which we actually recorded this here session. And you'll see two columns, one for people's preferred language and one for people's preferred problem. You'll see that a few folks sort of jumped the gun a few hours even before class began, but that's great, all the more enthusiastic. But as I scroll down here, you'll see there's a lot of data coming in, a couple of hundred responses already. And so let's go ahead and use this data now to actually manipulate it, to search it, to sort it, and actually ask questions about this here data. And in order to do this, what I think we're going to do is first talk about what are called flat file databases. A flat file database is kind of the simplest type of database in the world, whereby you just use a text file, a file in which you can store maybe some rows and columns. But that's actually not really possible in text files alone, because of course in text files you literally just have text. So you can put any characters you want on the screen. You can maybe have different lines of or different rows of text, but we probably ideally need some way of delineating the data that's inside of that file. And one of the most common ways to do this is via a file called CSV, comma separated values, which is a file format via which we can store really a simplistic database in purely an ASCII or really a Unicode file. And what this means is that all of your data in a CSV file is stored row by row by row, or technically line by line by line. So each entry has a line of its own. But for the notion of columns, you can do this in a number of ways. But the simplest way, as in the CSV format, is to just put a comma in between the values that you are actually collecting. And then, so long as you're using software like a spreadsheet or maybe Python code or something else altogether, you can tell that software to interpret those commas as really delineating where one column ends and the next column actually begins. So it's a nice lightweight format using a very familiar tool like a text editor to actually store some data that we might care about. And in fact, what's nice about collecting data via forms nowadays, whether it's with Google Forms or whether it's with Office 365 or the like, is that you can actually export all of the data ultimately in exactly this format, CSV. So in fact, let me go back over to my actual browser here, and you'll see that we indeed have some more data, some more rows that have come in over time here. And if I go up to the very top of the screen and drop down the menu here, you'll see that under the File menu, under the Download submenu, I can actually download this data set in a bunch of different formats. Microsoft Excel, with which many of you are probably familiar, PDF, although that really won't lend itself to manipulating it very easily with code, HTML if I want to make a web page out of it. But you'll notice at the bottom, there's actually a couple of options, one of which we've talked about already, namely CSV, for comma-separated values. There is an alternative called tab-separated values, which also is a convention too, whereby to delineate columns, you simply hit the tab key to kind of shift the data over. But I dare say CSV is probably a little more common, if only because a lot of text editing programs nowadays automatically convert tabs to spaces. Indeed, CS50.dev and VS Code, as configured, does exactly that. So CSV is a little more robust. So I'm going to go ahead and click on comma-separated values. That's going to drop a file into my Downloads folder on my here computer. I'm going to go over to VS Code now, minimize my window for just a moment, and then open up my File Explorer, which initially has nothing in it for today. I'm going to go into my macOS Downloads folder and simply drag this file over to the Explorer to essentially upload the file to my account. I'm going to go ahead now and hide my Explorer, maximize my window again, and hide my terminal window, and you'll see exactly that same data here, but clearly in textual format. Now, the file is by default called favorites-form-responses1.csv, but let me actually simplify that just to make my life easier. Let me open up my terminal window. And the command, recall, for renaming a file can be mv for move. And I'm going to rename that file favorites-formresponses.csv to more simply favorites.csv. Now let's go ahead and open up that same exact file, but under a different name now. And we'll see these rows and columns. But it's not quite as pretty as Excel or Google Sheets or Apple Numbers would be. We have to look a little harder for each of the commas. And indeed, in each of these columns, in each of these lines of text, rather, we have commas delineating one piece of data from another. But the very first row in this file is a little different. The first row is actually the headers of the columns that we saw visually in Google Sheets a little bit ago. And so that's actually that's actually pretty common in CSV files, whereby the first row and only the first row is somehow special. And most software will interpret that first row as being special, as really describing the data or the attributes or the records within each of those columns that follow line by line. Now, there is one curiosity here. Notice that the first line, really the second line after the header file, has three values: the timestamp at which the form was submitted, comma, the language that that person found to be their favorite, comma, and the problem set that that person found to be their favorite. But notice here, line 3 in the file, there's actually 3 commas instead of 2, even though there's still just 3 values. Why do we have the quotes around the name of this problem set, Hello World, whereas Scratch did not have a value, Tiedemann did not have a value, Mario did not have a value? Because we named that problem set hello, world, we need to make sure that the value is essentially escaped somehow, as with double quotes in this case here, to make clear to any software that's processing this data, be it again Google Sheets or Microsoft Excel or Apple Numbers or my own Python code ultimately, that there is something special going on in that string, and that comma should not be confused with the other commas which actually have meaning to delineate those columns. So what can I actually go about doing with this file? Well, let's actually go ahead and start answering some questions about the data here. I realized that not everyone got their response in from time because I downloaded the file just a couple of minutes ago, but I think this is enough data for us to play with. So let me reopen my terminal window here and clear my terminal. And why don't we go ahead and write a program in Python for now that simply iterates over this data toward an end of doing something interesting with it ultimately. Let me go ahead and create a program called favorites.py. And in this file, let's go ahead and do this. First, I'm going to go ahead and import a package called CSV. It turns out in Python, there's built-in support for CSV files, which is going to save me a huge amount of time because I'm not going to have to figure out how to open a file and iterate over every line and break on all of the commas and somehow load it into memory. The CSV module is going to do a lot of this for me. So I'm going to go ahead and say with open, quote unquote, favorites.csv, comma, quote unquote R, and this is going to allow me to open a file called favorites.csv, which is the shorter name. I gave that same file a moment ago. Quote unquote R means open it in read mode, and I'm going to give this a variable name of file, just so that I know how to refer to this file once it's open in memory. Then if I want to read this file line by line, it turns out thanks to this Python package called CSV, I can do this pretty easily. For instance, I'm going to create a variable called reader. I'm going to set that equal to the return value of csv.reader. So inside of the CSV package, there is a function called reader that is going to give me exactly that conceptually, some kind of object in the computer's memory that knows how to read CSV files. I have to tell it what file to read, so I'm going to pass in that same variable that I just got back from opening the CSV file itself. Now, for the moment, I want to go ahead and iterate over all of these rows. So for each row in that reader, and this is wonderfully useful Python syntax for just iterating line by line over this so-called reader, let's just go ahead and do something simple like print out the second column we see in that file. So recall that these columns are going to be 0 indexed as our Python lists. So 0 would be the timestamp, and I don't really care about that. 1 is going to be the favorite language, and 2 is going to be the favorite problem among our problem sets. Let me go down now into my terminal window, run python of favorites.py, cross my fingers as always, and voila, I seem to get out very quickly on the screen a list of all of the languages in that column. But if I scroll back to where I just ran that command, let's go up and up and up and up, all the way to that output, which is a ways away now, though I can clearly see visually a theme here among the most popular language in the group today. Let me keep scrolling back, and oops, there it is, my command that I ran earlier. There's one anomaly here. The options on that form were Scratch, C, and Python, and yet it would seem, based on my output here, that someone's favorite language is language. But that's a bit of a red herring, because recall that in favorites.csv, that first row was important. That first row had timestamp, capital T, because that's how Google does it, language in lowercase, because that's how I named the form, and problem in lowercase as well. So I seem to be getting a piece of my metadata, so to speak, the column name, and not only the languages in question. So how can I fix this? Well, there's a bunch of ways to do this, but the simplest way is actually to use a function in Python that just says next reader, which essentially means skip the first line of this file. Just next, and move on to the second row instead. If I now run this command again, let me do python of favorites.py, and just so I don't have to scroll through hundreds of lines of output, recall this cleverness in the Linux operating system whereby I can pipe the output of one command into the input of another command, like the command less. And as the name implies, this is going to show me less output from top to bottom. Let me go ahead and hit enter. And indeed, we see that the very first line of output here is Python now and not language. So a minor bug fix, if you will, but it at least now gets the job done. So at this point, we have a program in Python. It's only a few lines long that seems to know how to open a CSV file, read it line by line by line, and I have the syntax in Python to access particular columns. Bracket 0 for timestamp, bracket 1 for language, bracket 2 for problem, even though here I'm clearly only playing around with the column number 1. Well, what might I want to do? Well, let me take a baby step toward making this program more interesting. Let me clear my terminal window for just a moment. Let me go into my for loop here, and instead of just all in one breath printing out row bracket 1, let me actually create a variable, just for the sake of discussion, called favorite, so the current favorite language, and just set that explicitly equal to row bracket 1, and then print that out as favorite. So I haven't fundamentally changed anything about this program. In fact, I've kind of introduced a seemingly unnecessary variable, but I just want to be pedantic here about how we can make this program even more user or programmer friendly to me. So this is still going to work. Let me go ahead and run again python of favorites.py and pipe the output of that command into the input of less. And I again see the exact same input. But the reason I did this is because I want to improve this program now. It turns out that my program as written is a little vulnerable to changes in the CSV file. Like if you've used Google Sheets or Microsoft Excel, you probably know that you can click on those programs and drag to move the column to the left or to the right if you kind of want to reorder your data. And the problem with that is that if I, or if a colleague of mine, gives me a CSV file whose columns are now in a slightly different order, that's going to create a problem for my code, which is currently assuming that the favorite language is always in bracket 0. So the second column, the middle column among those three. But it'd be nice in general to make your code a little more robust against changes to the input so that things just don't break unbeknownst to you. So I'm actually going to introduce a different feature of the CSV package, whereby instead of using a reader, I'm going to actually use something called a dictionary reader or dict reader, which is going to give me back essentially not a sequence of lists, one per row, indexed by numbers 0, 1, 2, but it's actually this dict reader going to give me back a dictionary or dict for each row, so that instead of using numeric indices like 0, 1, and 2, I can actually use strings as keys to get at the data that I actually want. Specifically, I can use the names of the columns as defined in that first row of the file. So let me go ahead now and make a couple of other changes. We no longer need to ignore the first row of the file. So I'm going to get rid of this call to next, because the dictionary reader is going to assume that the very first line of the CSV file has the header names that I care about, and it's going to consume that row for me automatically before iterating over everything thereafter. And the reason I introduced this favorite variable a moment ago is because I wanted to be super explicit here that instead now of indexing into the current row as though it's a list with numeric indices, I instead am going to index into this row using strings as my keys, using the syntax for indexing into a dictionary instead of a list. And for that, I can simply do this, language, quote unquote. So row, now to be clear, is no longer a list in Python. It's actually a dictionary, but I can still use the same square bracket notation to index into this dictionary, but this time using the proper name of the column. So now, if I go ahead and clear my terminal, rerun this same command, piping the output through less so we can just see the first few lines, voila, it's still working as intended. But if I now were to go back to Google Sheets or Microsoft Excel and futz with the graphical user interface and move those columns around, download a new CSV wherein there's still comma separated values, but they're sort of in a different order, this code now will still work unless I or a colleague very difficultly, with great difficulty, changes the names of the column headers themselves, at which point things are still going to break. But at least now this is more robust against minor mistakes like reordering. Let's tighten this up again. I didn't strictly need that favorite variable, so let me go ahead and actually get rid of that and just more succinctly now print out row bracket quote unquote row bracket, I'm confusing the two, row quote unquote language to print out this current row's favorite language. So fairly straightforward there. But now let's actually solve a more interesting problem, because at the end of the day, all this program is doing is iterating over CSV, printing out all of the favorite languages. That's not really a step forward, because I could already see in Google Sheets itself all of the answers that I actually cared about just visually with my own eyes. But it'd be nice now to maybe crunch some numbers. And it'd be interesting to know, among the people that submitted this form in time before I downloaded it to my code space, how many people do prefer Scratch? How many people do prefer Python? How many people do prefer C? Well, it looked at a glance that Python was definitely visually the biggest contender, but let's quantify that now. So let me go ahead and make this program a little more interesting, whereby I'm still going to import the CSV package up here. I'm still going to open the file down here, and I'm still going to use my dictionary reader. But this time, instead of just blindly iterating over the file and printing things out, let's actually create a few variables. So one, let me create a variable called Scratch and set it equal to 0. Let me create a variable called C and set it equal to 0, and a variable called Python and set it equal to 0, so that I have three variables via which I can count how many people like Scratch, how many people like C, how many people like Python. Now, this is a little bulky visually, so stylistically, there's actually a slightly more elegant way to initialize multiple variables at once that I'm going to avail myself of here, just to make the point that I can. Scratch, comma, C, comma, Python equals 0, 0, 0. And there's other ways still to achieve the same goal, but this is just a little tighter. Instead of wasting 3 lines, I'm using 1 line to do exactly the same thing. This has nothing to do with CSVs. It's just a coincidence that I'm using commas on this line 5 to separate my variables and these values, but it's a Python trick if you want to initialize multiple values at once to a value like 0. Now let's bring back that for loop. So for each row in that dictionary reader, row by row by row, let's go ahead and grab the current row's favorite language, as we did earlier. And now let's use some conditionals to check what that favorite is. So if that favorite equals quote unquote scratch, well, then let's go ahead and increment our scratch variable by 1. Else, if the favorite value equals C, then let's go ahead and increment our C variable by 1, just as with scratch. Else, if the favorite equals Python, then let's go ahead and increment our Python variable by 1 instead. Now, technically and logically, I could have just used an else at the bottom of this conditional, but just in case someone slipped in a fourth language that I don't want to talk about yet into the file, or maybe the form changed, but my code doesn't know about it, I don't want to mistake some random other value for Python, so I'm just going to ignore, logically, any rows that don't equal scratch or C or Python in this case. Now, at the bottom of this program, outside of that loop and outside of the file itself having been opened, which because of the width will be automatically closed now, let's just print out these 3 values. So let's print out, using, say, a format string, just so it looks a bit pretty on the screen, that the total value for scratch is going to be whatever is inside that scratch variable. Let's print out on the screen another format string that says whatever the value of the C variable is. That's how many people love C. And then lastly, let's print out another format string with Python as its prefix and print out through interpolation there of the variable Python, how many people really liked Python. So if I didn't make any mistakes here, I think I can reopen my terminal window now, run Python of favorites.py. I'm pretty sure that the most popular language, just based on a glance earlier, is going to be Python, but let's see if we can quantify it by hitting enter. And indeed, it looks like 11 of you like Scratch, 59 of you like C, but 243 of you prefer Python. So glad to see that it's only getting better and better, it would seem, here over the weeks. So how did we go about doing this? Well, very mechanically, right? I wrote a decent amount of code here, some 17 or so lines, just to iterate over that file, create some variables, increment them as needed. And this is totally fine. It's not an unreasonably long program, but I do think it's getting a little wordy, if you will. It seems like we're spending an awful lot of time sort of building this up, when it would be nice if we could maybe simplify this code a little bit, because this is kind of a common paradigm. You get some data set as input, someone, maybe it's your teacher, maybe it's your boss, maybe it's your own curiosity or asking questions about that data, you'd like to provide answers. Well, how can we go about improving this kind of code and doing something a little differently? Well, let me propose that we revisit this idea of dictionaries themselves. They've already been useful in the context of this dictionary reader because we can get handed back more user-friendly dictionary objects instead of rows, each of which represents a row of our data. And recall that a dictionary really is just this. It's a set of key value pairs. And it's sort of the Swiss Army knife, if you will, of programming, because it's actually very powerful to just be able to associate one thing, a key, with another thing, a value. So in fact, instead of having, for instance, 3 separate variables just to keep track of all of those counts, why don't I draw some inspiration from the world of dictionaries and maybe use one dictionary to keep track of all 3 of those languages? And this has been the thematic. Way back in C, recall that we initially would often create 1, 2, or more variables, and then we realized, no, there must be a better way, and there was. In week 2, we introduced arrays, which allowed us to have one variable containing multiple similar values. And now with Python, because we have these full-fledged dictionary objects, that's just to allow us to associate arbitrary keys with arbitrary values, we can use that a little more readily and keep our code a little cleaner too. So back here in VS Code, let me go ahead and propose that instead of having all 3 of these variables here, and in fact all of these conditionals here, let's get rid of most of that code in the loop, and instead let's just create a new variable, for instance called counts, that's going to be an empty dictionary. And recall that 2 curly braces open and close together with nothing inside in Python gives me an empty dictionary. Sort of a table that's ready to go, looks a little something like this, but with nothing in it initially. But it's now one and only one variable. All right, now let's go ahead and iterate for each row in that reader, just as before. Let's go ahead and grab the current row's favorite by using the dictionary we just got back from the reader, indexing into it via the column name language. And now, instead of having those 3 conditionals using 3 different variables, let's be a little more elegant. Let's just say that we should go into the counts dictionary, index into it at whatever this name of the language is, and increment that by 1. In other words, use the current language, Scratch or C or Python, as a key into the counts dictionary, and whatever its value already is, increment it by 1. Now this is close, but actually a little buggy. It turns out if you just blindly index into a dictionary using a key like Scratch or C or Python, but that key isn't yet there, that's actually a so-called key error. You can't just blindly use a key that doesn't yet exist and try to increment it, because what are you incrementing? There's no data actually there. There's no row in this table to go increment the value thereof. So I do need to be a little more careful here. Let me instead do this conditionally. So if the current favorite language is already in the dictionary called counts, then okay, go ahead and index into the counts dictionary using that favorite as your key and increment that value by 1. Else, if it is logically the case that that favorite language is not yet in the dictionary, that is to say, there is no key for it yet in this dictionary, okay, no big deal. Let's index into that dictionary, but assign it a value of 1. So if it's already there, well then presumably we've seen it before, so we want to increment the total value. But if it's not yet there, we just want to assign it a value. So in both cases, we're indexing into the dictionary, but we have to make sure that we're only incrementing an existing value if it's there, but we're initializing the value to 1 for this current row's favorite language if we've not seen this same language before. Now, at the very bottom of this program, let me go ahead and get rid of all 3 of these printfs and just do something a little simpler. Let's go ahead and iterate over every favorite key in that counts dictionary. And again, this is sort of Pythonic syntax whereby you don't have to worry about what's the key, what the value is. If you just iterate over a dictionary using syntax like this, the favorite variable that I'm creating in this here for loop is going to be initialized to 1 by 1 each and every key in that dictionary, presumably 3 in total, given the data we have. So inside of that loop, let me go ahead and print out a format string containing the name of the language, using curly braces to plug in that value, and then let's go ahead and output with another set of curly braces whatever the value is of that key by indexing into that dictionary inside of curly braces, and then closing the quote on the outside, which should give me language count, language count, language count by iterating over that dictionary. All right, crossing my fingers as always, let me reopen my terminal, let me rerun Python of favorites.py, and voila, we get the same counts. Now I will note they're slightly differently ordered. I think earlier we saw Scratch and then C and then Python, but in this case we're actually seeing Python and then C and then Scratch. And this is subtle, but does anyone have an instinct for why this is the case? Why did my ordering suddenly change now that I'm using a dictionary instead of 3 explicit print calls? It's ordered by default based on the order in which we inserted those keys. And so the answer actually lies in favorites.csv itself. If we go back to that file here, you'll see that someone's favorite language as of the second row in this file was Python, though curiously their favorite problem was Scratch, so I'm not quite sure how to reconcile those two, but their favorite language, Python. The next person's favorite language was also Python. Oh, the third person's language was C, and then if we go down and down and down, I think we'll eventually see Scratch. And so dictionaries nowadays are ordered in the sense that if you insert one key before another, and then you iterate over that dictionary later, you're actually going to say the same ordering thereof. Whereas I previously in my code had full control over all 3 print statements, so it seems to be an opportunity for us to perhaps sort these via key or maybe even value. In fact, one is a little easier than the other, and let me go back into my favorites.py here and propose that we do that. Let's first sort by the counts themselves. So this is actually a relatively easy change. Down here in my for loop, instead of just blindly iterating over the dictionary from first key to last key, let's actually sort those counts first by using Python's sorted function. And then in my terminal window here, let me run Python of favorites.py again, enter, and now you'll see that I've actually sorted them by the keys themselves, C and then Python, then Scratch. So it's not the same order in which I printed them. Now it seems to be doing it alphabetically, but I do seem to have some control over how I'm printing this here file. All right, but what if I actually want to be a little more clever and print these things out in order of their values, not their keys. So I don't really care about alphabetization. At the end of the day, I really want to know what's the most popular, what's the least popular. How can I go about doing this? Well, in my same code here, let me hide my terminal window for a moment. And let me add a bit more syntax to the sorted function in Python. It turns out if you want to do this, you can actually specify what key to use to sort the dictionary. And I'm going to use a clever trick here whereby I write key equals counts.get. And that's going to tell the sorted function that I actually want you to get the value from the counts dictionary and use that as your sorting key. So don't use the actual key in the dictionary as per our slide here. Instead, use as your key whatever the value is of the counts dictionary itself. So sort by count. Let's go now and open my terminal window again. Let me rerun favorites.py, and I'm going to leave the previous run on the screen so we can see now that this one, so close. So it's clearly not alphabetically sorted anymore, so that's good because I didn't care about alphabetization, but it seems to be sorted how? From smallest to largest, so from least favorite to most favorite. So that's kind of backwards, but not to worry. If you consult the documentation for Python's sorted function, you'll see actually that there's another argument we can provide to sort it. Let me clear my terminal here and close it for a moment. And let me say that, you know what? Whatever you do with sorting, go ahead ultimately and reverse it. So set reverse equal to true. Clearly, the default value must be implicitly false. But if I reverse that order by getting each count, now if I run Python, or Python. Now if I run Python of favorites.py, enter, now finally, all these minutes later, I have a proper analysis of everyone's favorite language ordered from most favorite to least favorite. The code itself, not terribly long, still 14 or so lines, but it's kind of a decent amount of effort just to get to this point. I had to write a decent amount of code, add a decent amount of complexity, just to get a simple answer. And you can imagine that. You glance at the Google form, or your boss glances over your shoulder and asks, what's everyone's favorite language? It'd be nice to be able to answer that super quickly. Ironically, just like Google can, just like Microsoft Excel can, just like Apple Numbers can, because typically you can sort of highlight the data, and then in the bottom right corner nowadays, you can see a quick summary maybe of the max value, the min value, the sum, the average, or you could use functions built into a spreadsheet. It almost seems like I have to make more work for myself in code, at least with Python, to answer those same kinds of questions. But not to worry, that's why we're introducing ultimately a new language today, SQL, via which we can actually get back that speed, that flexibility that you already get in graphical interfaces like spreadsheets, but you can also use that technique programmatically in code as well. But before we dive in, let me pause and see if there's any questions on what we've just done here in Python. A really good question, and we'll come full circle to the answer to that actually toward the end of today's lecture, because we will reintroduce Python at some point, because it turns out as you learn more and more languages and you tackle more and more sophisticated programming projects, it's actually very common, very compelling to mix programming languages sometimes. And so you can actually use SQL inside of Python, in fact, any number of other languages, because yes, sometimes you'll find it easier to bring back a more multi-purpose language like Python to get some job done, but you still want the flexibility and the ease of use of querying for your actual data. The equal signs here. So in my code on the screen right now, I'm using a single equal sign quite a bit, and that's for the assignment operator in Python, whereby you assign a value from the right of the expression to the left. I don't have any equals in this here code, because recall that equals in C as well as in Python is for comparing two values for equality, left and right. So I previously in my conditional version did use equals to actually compare the favorite value against quote unquote Scratch, quote unquote C, quote unquote Python. But here now, I'm only using a single equal sign for assignment. A good question. All right, so let's transition now to a proper database for this here data. And in fact, we'll focus today on what are generally called relational databases, which is a piece of software that allows you to store data, thus a database, but in such a way that you can relate some of your data to other data. In other words, instead of just throwing in all of this data messily into like a folder, much like on your Mac, your PC, or even your phone, you can actually store it a little more methodically, a little more algorithmically, if you will, by baking into the database some kinds of relationship